Hello, so this is A-Level Physics Winter 21 Paper 1 Variant 2 and let's start with question number 1. So question number 1 says that which row shows that what all physical quantities must have. So physical quantities must have magnitude and unit. Direction is not important, so this is correct, this is correct. C is the appropriate answer. Question number 2 says that what is an alternative way of expressing an energy of 43 decijoules? 43 deci means 43 into 10 raised to the power negative 1 joules, which is 4.3 joules. So seeing part A is 4.3 into 10 raised power 3 milli, which is 10 raised power negative 3 joules. So this cancels, so 4.3 joules. So A is the appropriate answer. A tennis ball is hit so it leaves the racket with velocity v at an angle theta to the horizontal. The vertical component of the velocity is vy. What is the magnitude of the horizontal velocity component of the velocity v? And that is, this thing is being asked, and this thing is given, which is vy, and this is our v. So it asks about its v. It's v cos theta. It's basically v cos theta, which is not given in the option, so it must be the in terms of the resultant force. So let's find the resultant of the horizontal component, that is square root of v square minus vy square, considering from the Pythagoras theorem. So D is the proper answer. Question number 4 says that the CRO readings are given. Which screen shows the waveform of the same frequency? So seeing the time period, the same time period would have the same. So number 1 has 1, 2, 3, 4 blocks multiplied by 0.02. So 0.08 second is the time period for number 1. 1, 2, 2 into 0.04, which is 0.08. So 2 and 1 have the same time period, so they have the same frequency, so A is the appropriate answer. So question number 5 says to measure the percentage uncertainty in the value of G and V are given with the absolute uncertainties of length and time period. So let's first make T the subject. So that will become T square equals 4 pi square L over G, and G becomes 4 pi square L over T square. So let's now find the percentage uncertainties in length and time. So the percentage uncertainty in length can be found from 0.001 by 0.420 multiplied by 100, which makes up 0.238. And percentage uncertainty in time can be found from 0.1 over 1.3 multiplied by 100, which gives us 7.7%. So in order to find the uncertainty in the value of G, we need to add the lengths. Percentage uncertainty is length percentage uncertainty plus 2 into applying the power rule time uncertainty. So this becomes length uncertainty 0.238 plus 2 multiplied by 7.7. So this makes up 16%. So D is the appropriate answer. Question number 6 says that the graph shows the variation with time t of the velocity. The vehicle moving at 4 meters per second begins to accelerate at time t is equals to 0. What is the vehicle's acceleration at 3 seconds? So at 3 seconds we have drawn a tangent line, and now we need to find the gradient of this slope. So the slope of this line is change in y over change in x, which is 10 minus 2 over 6 minus 0, which makes up 8 over 6, 4 over 3, which is 1.3 meters per second square. C is the appropriate answer. Question number 7 says that a stone is projected vertically upwards from the ground at an initial velocity speed of 15 meters per second. So Now it says that the air resistance is negligible. What is the maximum height reached by the stone? So it is released at this height. At maximum height, it must have final velocity of 0. Initial velocity is 15. Acceleration would be negative 9.81. So we need to find the height, the displacement. We can apply v square minus u square equals 2as. So v is 0 minus u square equals to 9.81 into the displacement. So the displacement s can be solved and found to be 11 meters. So B is the appropriate answer. Question number 8 says that what is meant by the mass of an object? The property of an object that resists a change in motion. So A is the appropriate answer. So question number 9 says that the diagram shows two parachutists vertically moving downwards. The total mass of the parachutist Y is and his parachute is twice. So the mass of the Y is 2m and the parachutist X is m. So air resistance on parachutist Y is, so the force of air resistance is 2 times, so it becomes 2f, twice air resistance on parachutist X, so the force of air resistance is f air. Neither parachutists have reached the terminal velocity. Which statement describes the acceleration of the compared to x with y? Let's find the acceleration and then see the options. So for this, F equals ma for x. Net force is ma becomes mass into acceleration equals weight, which is mg, in this case minus f air. So the acceleration would become mg minus f air by m. So this is our equation number 1. For this, our F is equals to ma would become, the mass is 2m. So F equals mg is 2mg, the weight and the air resistance, which is 2f air, weight and the air resistance. So this becomes F equals 2mg minus 2f air, as it says in the question. So 2 cancels out from the whole equation, and again the acceleration becomes mg minus f air divided by m. So acceleration is same for both. So B is the appropriate answer. So question number 10 says that which shows perfectly elastic collision. So part A and B, they are sticking together, so that's not elastic. In part C, let's apply the formula u1 minus u2 equals minus v1 minus v2. So over here, let's see C part. So this becomes 2 positive 1 equals minus 2 positive negative 3. So this becomes 3 negative 3, 2 negative 3 is negative 5 positive 5, so this becomes 5. So this is not true. So let's see D. So that is u1 minus u2, that is 3 minus 1, 4 minus 1 is 3 equals negative v1 minus v2, v1 is 1 minus 4, so this becomes 3 equals negative 3, so 3 equals 3. So this satisfies the equation for the perfectly elastic collision. So that's it for this video. Do like and subscribe my channel. I will continue the rest of the questions in the next video. Thank you.